Hi all, welcome to the session of design and analysis of algorithms. In this session, we discuss about performance analysis. The agenda of the session includes how to evaluate an algorithm, what is the space complexity, what is time complexity, and how to calculate them with examples. The first question comes to our brain is how to evaluate an algorithm. Any algorithm is evaluated based on their performances. The performance evaluation can be done in two different ways, either before the execution of a program or after the execution of a program. Before the execution of a program, it is termed as priori estimate. It is also known as performance analysis. Once it is executed as a program, then we are analyzing the performance. It is termed as posteriori testing, also called as performance measurement. Performance analysis mainly deals with the time and the space required for the execution of an algorithm. Hence, we focus mainly on time and space requirements for the algorithm. This performance analysis includes the calculations of time complexity as well as space complexity. Let us see what is space complexity. The space complexity of an algorithm is the amount of the space, that is the memory, required by the algorithm to run to completion. The space required is a sum of two components. It may be either a fixed space or it may be a variable space. Fixed space is independent of input and output supplied to the algorithm. Example, instruction space. The number of instructions will be fixed. Space for the variables. The variable space is also fixed. The space for the constant, which is also fixed. Such space requirements come under fixed spaces. The other one is variable spaces. This is absolutely depending on the problem which we are solving. Example, reference variables. The reference variable spaces vary based on the problem. Similarly, recursion stack space. The recursion stack size depends on the number of times of recursion. Hence, these two spaces are depending on the problem instance. They can be termed as variable space. Now, if I assume P is an algorithm, S of P is the total space required for an algorithm, then S of P is equal to C plus SP, where C is nothing but a fixed space which is always constant, and SP is the variable space which varies depending upon the problem. So when we analyze the space complexity, we majorly focus on SP, that is variable space, but not on the fixed space. This variable space is absolutely depending on the instance characteristics. Let us see with an example. Consider the example algorithm to calculate sum of n elements in an array A. Now, in the example, we require a space to store the variable value n. Let me assume the space required is 1 word. We require space to store n values in an array. Now, the size of the array will become n. So, therefore, we require n words to store the array. We do have a loop variable I, which is iterating from 1 to n. Therefore, I require to store the value of I require space 1 word. We are calculating sum in the variable s. So, to store it, we require 1 word space. Now, the total size required is n plus 3 words. Hence, I can say that the space required to calculate the sum of n numbers in an array will be greater than or equal to n plus 3 words. Let us see an example of recursion. Let us implement the sum of array of n elements using recursion algorithm. If n is less than or equal to 0, the return zeros. Else, I will calculate a of n plus recursion sum of a of n minus 1. Now, in this case, the space requirements are as follows. Any recursion call involves the space for local variables, the space for return addresses, as well as the pointer. Here, R_sum is a recursion call. It requires the return address, that is one word, and a pointer to point an array, one word, and has a local variable n which requires one word. So, every call for recursion sum requires 3 words. How many recursions do we call? For the sake of calculation of n elements, we require n plus 1 recursion calls. That is, the depth of recursion is n plus 1. Now, the total space required is n plus 1 recursions, each of having 3 words, a total of 3 into n plus 1. Hence, I can say that the recursion sum for calculating the sum of n elements in an array will be taking 3 into n plus 1 steps. Let us see now what is time complexity. It's very simple. The time complexity is nothing but the total computer time taken for completing our algorithm. Now, time complexity also has 2 components. One is the compile time and runtime. The compile time will never depend on the input or the output being supplied. That is, it is not depending on instance characteristics. And as we all know that once a program is compiled, it can be run several times without any compilation. Hence, I can say that compile time is constant time. Come to the runtime. The runtime always depends on the input and output. That is, it always depends on the instance characteristics. It depends on the problem instance. Hence, it is a variable time. So, the time complexity is calculated as runtime plus compile time, where compile time is constant. If I assume P as an algorithm, T of P is the time complexity, it can be given as sum of C plus Tp, where C is the compile time and Tp is the runtime. How to calculate time complexity? One of the easiest methods to calculate time complexity is count the number of steps for each statement in the program. What is a program step? A program step is nothing but a meaningful segment in a program that has an execution depending on instance characteristics. Note that all the statements in the program may not have executions all the time. So we are bothered only the executable statements in the program. First, identify the executable statements in the program. After identifying the executable statements in the program, count the number of steps for each program statement depending on kind of statement. Then, how can I count it? For example, if it is a comment, it is not being executed at all, and it takes 0 steps. If it is an assignment statement, it takes only 1 step to assign the value. If it is a condition, to check the condition, it takes only 1 step. If suppose it is an iterative statement or a loop, to reiterate n times, it takes n plus 1 steps, where n steps will check the true condition and n plus 1 step will check the false condition. When a loop is having n plus 1 step, the body of the corresponding loop will execute for n steps. Based on this number of steps for each program statement, we can calculate the time required for an algorithm. Let us see the examples. The first example, the algorithm for calculation of sum of array elements. The first line is not executed, hence it is written as 0. The second line is also not executed, hence it is written as 0. The third line, s is equal to 0, is an executable statement. For I is equal to 1 to n is also an executable statement. S is equal to s plus a of I is also executable statement. Return yes is also executable statement. Closing braces is not an executable statement. Initially, we identified the executable statement. Now let us try to find the frequency of each executable statement. S is equal to 0 is an assignment statement. Hence the frequency is only one step. For I is equal to 1 to n is an iterative statement. Hence the frequency is n plus 1. S is equal to S plus A of I is an assignment statement which is n corresponding to the loop. Hence it is executed n times. Return S is a returning statement which returns a value, hence it is executed one time. Now let us calculate the total steps. 1 into 1, 1, 1 plus 1 into n plus 1, n plus 1, 1 into n, 1 into 1, 1. A total of 2n plus 3. The total time required is 2n plus 3 steps for this algorithm to calculate the sum of n elements in an array. Let us take one more example. This example is used to add the sum of two matrices A and B of order m into n. The first two steps are not executable. The loop is executable step. The jth loop is also executable step. The calculation is executable step. For I is equal to 1 to m, this loop executes m plus 1 times, and the body of the loop, both statements will execute m times. But in the body, there is another loop for j is equal to 1 into n. It also executes n plus 1 times. Its body, c of ij, will execute n times. Hence, the total will be 2mn plus 2m plus 1 steps. Now let us see how to calculate the time complexity for the sake of recursion algorithm. If I consider recursion sum for the n elements in an array, if there are no elements, then return 0. If there are more elements, you calculate A of n plus recursion sum. The executable steps are: if n equal to 0 is executable step, return 0 is executable step, return r sum of a n minus 1 plus A of n is an executable step. Here there are two conditions: if n is 0 or greater than 0. Now, if they consider the case where n is equal to 0. If n is equal to 0, this condition is verified, so it is executed 1. As the condition is true, therefore it is returned 1. And the other statement is not executed. Hence, the total number of steps required when n is equal to 0 is 2. If suppose n is greater than 0, the condition is checked once. As the condition is false, the statement is not executed. Then we are going to the return statement of r sum. This statement is executed one time. But how many times it executes? 1 plus x times, where x is the time taken for this recursion sum. That is t of n minus 1. Therefore, the total time taken when n is greater than 0 is 2 plus x. Put it in a word, if t of n is the time taken for this algorithm, it will be 2 when n is equal to 0 and 2 plus t of n minus 1 when n is greater than 0. In this session, we discussed what is a performance analysis, time complexity, space complexity, and their examples. Thank you.